So this is the final outcome of a project. So the main aim of the project is to AI-based deep learning technique for demand and forecasting of power uses, peak load of forecasting of power uses, electricity uses. To implement this project, we used a Python Flash framework for the UI, and today we took a dataset of electric demand dataset, electric load forecasting dataset from Kaggle, and we made train of the dataset by using LSTM and GRU algorithms, and we save that model and we use for the prediction. Okay, and here the overall accuracy while training we got 99.2% of accuracy, and precision with 96.4%, recall with 97.3%, and we have around data points, how many data set we have. Okay, this is the home page. Okay, here we no need to use up any kind of database because here we gave a static login credentials, so that's why we no need to use up any kind of database here. This is the home page, landing page, so where it's going to display the title name as well as what are the features we have: LSTM neural network, GRU neural network, peak load forecasting, and weather integration, dataset management, performance analysis. Okay, now the workflow: first we are going to make upload dataset, then we are going to make a train the models by applying the algorithms on dataset, and we are going to the get predictions, and we are going to make a analyze stack, and we use here tech stack of Python and TensorFlow, Flask for web UI, Keras and TensorFlow for training of dataset, and NumPy Pandas for mathematical calculations for accuracy and all, and scikit-learn which is going to which model file we have used, we have created to load that model file in a code, and chart.js which is helpful to show the graphs and charts. Okay, so here we are going to make a login. So this is the login. So we gave a static login credentials. Okay, in code only we are going to give that. Okay, and after that now we are going to make a upload of a dataset. So here we have a dataset we are going to upload. Okay, so in dataset how many total records we have? 48,000 records we have, and 17 features we have in that. After that, so the time resolution is hourly time resolution in that. So dataset columns we have date, time, NAT, demand. So these are the main features in a dataset. So for prediction of target, so holiday ID, WSMG, TQL, see. So we can see the preview of a dataset up to 10 rows it's going to display, because we have 48,000 of data, we can't display here directly. Okay, and we are going to make a click train and test. Now the LSTM and GRU models are being trained on a dataset. Okay, so once the training is finished, so we can move to the prediction phase. So training GRU model and evaluating and saving models. So these models is going to save in our project folder. So now we can go to predictions. So here we can give temperature and all, so how much you know and all. Okay, so liquid, holiday ID, we can give holiday ID. So here we can see, so the demand is 583.49 megawatts, so ensemble is 514.83 megawatts, and GRU model is going to show 446.7 megawatts prediction demand. So demand level is 500, so here we have a low demand. Now we will check with some more some more data we can give. So holiday, so here also you can see the low demand. Okay, so which one LSTM is going to get a more megawatts prediction demand. Okay, so and we can go to the view performance page, which is going to show the performance analysis, so how much of accuracy we got, precision, recall and all. Okay, so GRU model, so based on the dataset what we have chosen, so based on that it's going to show. So these are the graphs, actual, LSTM and GRU. Okay, so mean attribute error, this is the mean attribute error, and this one is the original mean attribute error. Okay, so these are the graphical representations of R square score, F1 score, recall and precision accuracy values. Okay, and this is the graph prediction error, and this is the accuracy score what we have got. So logout. So this is the final outcome of a